In this video, we'll be having a look at the following integral. We have to evaluate the integral of x squared over e to the x plus 1 dx from -2 to 2. So this is a definite integral. If you like, you can pause the video and have a go at the problem on your own before having a look at the solution. Okay, let's have a look at the solution. Okay, so what I'll do is I'll use substitution of u equals minus x. And maybe a brief reason why the substitution is nice is because we have a -2 and 2 as the bounds of the integral. So when you do u equals minus x, the bounds will be swapped, and that is quite nice. So when we make u equals minus x, that's the same as x equals minus u. And we can write du as minus dx or dx equals minus du. And we see the bounds, so x equals 2 will become u equals minus 2, and x equals minus 2 becomes u equals 2. Then we can, if we let I equal our original integral over here, we can set, by making the u substitution, I will also equal, so now we have 2 to minus 2 as the bounds because we take the negatives, and the x becomes replaced with a minus u, and the dx becomes replaced with a minus du. So we can write I in this form. And we can now equate this, so we get a minus u squared, so the minus is from here, and then divided by e to the minus u plus 1. And now we can swap the bounds. So if we swap the bounds, then the minus sign goes away. So we have the bounds going from -2 to 2, and u squared over e to the minus u plus 1 du. And now we can multiply the numerator and denominator by e to the power of u. So we get integral of e to the u squared over 1 plus e to the u du. And so we have equivalent expression for I in terms of u here. And we can just change the variable of the integration back to x. So we now get I as the integral from -2 to 2 of e to the x squared over e to the x plus 1 dx. This gives us two different expressions for I. So I can be written as the integral from -2 to 2 of in two different ways, like this and this. And now the nice thing we can do here is what happens when if we add these two equivalent expressions for I. We can see what happens when we have 2I equals, when we sum these two expressions, there is common factor of x squared over e to the x plus 1, and we get e to the x plus 1 here. And the nice thing is we get a cancellation of e to the x plus 1 on numerator and denominator. So this gives us the integral of x squared dx from -2 to 2, and this becomes 1 over 3 x cubed from -2 to 2, and by substituting we get 8 over 3 minus -8 over 3, which is 16 over 3. And this is the value of 2I, so dividing by 2 gives us the original integral is equal to 8 over 3. Okay, so that completes the solution for this integrals. And just note that we didn't find the indefinite integral here, so this method only works for finding definite integral directly without using the indefinite integral. Okay, so hope you enjoyed this video. Thanks for watching, and I'll see you next time.